You have never met another version of yourself, so you have quietly assumed there is only one of you, one Earth, one Sun, one history that actually happened. It feels obvious. But that belief was never built on evidence. It was built on the absence of it. We have only ever seen a single sliver of the universe, about 93 billion light-years across, and that is not the size of everything, only the distance light has had time to cross since the beginning. Measure the shape of space, and it comes back flat to within 0.2%, and a flat space, as far as we can tell, never ends. Now set that beside a stranger fact. A region the size of everything we can see holds only a finite number of atoms, a 1 followed by 80 zeros, arranged in only a finite number of ways. Finite arrangements, scattered through endless space, force a conclusion most people are not ready to hear. Somewhere out there, the same arrangement happens again, the same Earth, the same room, the same you. Get comfortable. Hit subscribe if you are new here, because by the end of tonight, the word you will no longer mean one person, but countless, scattered through a universe with no end. Now, let's slowly ease into this. Part 1. The story you were told about yourself. Tonight we are going to follow a single idea as far as it will go, and the place it leads is stranger than almost anything in science fiction, even though every step of the path is built from ordinary, measured physics. The idea is this: somewhere out there, right now, there may be another version of you, not a spiritual twin, not a metaphor, not a poetic way of saying that we are all connected. A real, physical person, built from the same kinds of atoms, living inside the same universe you are living in, who is either identical to you in every single particle, or differs from you by exactly one small choice made this morning, depending on which layer of this story we are standing in. And there are several layers. We will walk through all of them slowly, and we will take our time, because none of this is the sort of thing that should be rushed. Before we go any further, settle in, and let me say one quiet thing about where we are going. The point of tonight is not to unsettle you. It is closer to what happens when someone tells you something true about a room you have lived in for years, something about its history you never knew. The walls do not move, the furniture stays where it was, and yet the room is the same, but it isn't anymore. Hold on to that phrase. We are going to come back to it at the very end, and by then it will mean something larger than it does right now. If you have ever sat with a question that made the space around you feel slightly different afterward, the kind of question you find yourself carrying around for days, then you already know the feeling we are walking toward. Most people carry an assumption about the universe that feels so obvious it is never examined. The assumption is that there is one of everything, one Earth, one Sun, one history that actually happened, one version of you, the one that woke up in your bed this morning. We assume that even if the universe is far too large to ever explore, there is still, somewhere underneath it all, a single set of facts, a single truth about what exists. That feels reasonable. It matches everything you have ever experienced. You have never met another version of yourself. You have never bumped into a second Earth. You have never opened a door and found a copy of your own living room with a copy of yourself sitting in it. So, the natural conclusion, the one almost everyone draws without ever noticing they have drawn it, is that there is only one of each thing, and only one of you. Here is where the first crack appears, and it is so simple that it is easy to walk straight past it. The belief that there is one of everything is not based on evidence. It is based on the absence of evidence. And those two things are not the same. We have never detected a duplicate of you. That is true. But we have also never been able to look at more than a tiny sliver of what might actually be out there. We have never seen the whole stage. We have only ever seen the small lit circle we happen to be standing in, with darkness in every direction beyond it. Concluding that there is one of everything, because we have only ever seen one, is a little like standing in a single windowless room and concluding that the house has exactly one room. It might. But you have not actually checked, and the feeling of certainty you have is not the same as having looked. The reason this matters is that the universe might be unimaginably larger than the part we can see. Not twice as large, not 1,000 times as large. Larger by an amount that ordinary language was never built to carry. And if it is, then mathematics and probability begin to do something that makes most people genuinely uncomfortable when they sit with it long enough. Not because the math is exotic. The math is the kind of probability you could explain to a curious child with a handful of coins. It is uncomfortable for a different reason. It is uncomfortable because of where that simple, familiar math points the moment you aim it at a genuinely endless universe. The arithmetic does not change. The stage it is performed on becomes infinite, and on an infinite stage, even the most modest arithmetic starts saying things that sound impossible. It is worth saying, before we start walking, that we have made journeys like this one before, as a species, and come out the other side more at home in the universe, rather than less. Every time we have learned that we were not at the center of things, that the earth was not the middle of the heavens, that the sun was one star among many, that our galaxy was one among uncountable others, the news arrived sounding like a demotion and ended up feeling like an enlargement. Tonight is the same shape of journey, carried one step further, all the way down to the question of whether even you are one of a kind. So I am not asking you to brace for something bleak. I am asking you to come on a walk, the way you might step outside under a clear sky and let your eyes slowly adjust until more and more stars appear, until the sky you thought you knew turns out to have been mostly hidden the whole time. Nothing up there changed when your eyes adjusted, only your sense of how much was always there. That is very nearly the whole of what tonight does. The universe does not grow colder as it grows larger. It grows stranger and, if you let it, far less lonely. So that is the question we are going to follow tonight, patiently, one careful step at a time. If the universe is large enough, are you alone? Is there truly only one of you? Or does the same set of physical laws that built the stars and the planets and the slow machinery of life also build, somewhere far away, another person who is reading or hearing this exact sentence at this exact moment, having the exact thought you are having now? We are going to start with what we actually know, the things that have been measured, and we are going to build only on those. Then, step by step, we will follow where they lead, through 4 distinct layers, each one stranger than the one before. By the end, you are going to see your own existence a little differently, not with fear, more like the way you would look at that familiar room, knowing now what you didn't know before. Let us begin where the firm ground is, with a simple question of how big the universe really is. Part 2. The edge that isn't an edge. To get anywhere with this question, we first have to be honest about how big the universe actually is, and then about the difference between how big it looks and how big it might really be. When most people picture the universe, they picture something large. And it is large. The part of the universe we can observe, meaning the part whose light has had time to reach us since the beginning, is about 93 billion light-years across. That number needs to land properly before we go on, because everything tonight is built on it, and a number you have not actually felt is a number that cannot do any work for you. 1 light-year is the distance light travels in a year, which is roughly 6 trillion miles. So 93 billion light-years is somewhere around 550 sextillion miles. If you wrote it out in miles, it would be a 5 followed by 23 zeros. Let me try to make that less abstract, because written out, it is just a smear of digits. Imagine you got in a car and drove at highway speed, and you had been driving without stopping since the universe began, never sleeping, never slowing, just driving for the entire age of the cosmos. In all that time, you would have covered something like 1 trillion miles. That alone is hard to hold in the mind. And yet to cross the observable universe just once, you would need to make that drive, the whole drive since the beginning of time, about 550 billion trillion times over. It is a number so large that it stops behaving like a number and starts behaving like a feeling, a kind of vertigo, and that vertigo is honest. It is the correct response to the real size of the thing. Now here is the part that almost everyone misses, and it is the hinge the whole night turns on. That 93 billion light-years is not the size of the universe. It is the size of the part we can see, and those are very different claims. The reason there is an edge to what we can see at all is that the universe has only existed for about 13.8 billion years, and light travels at a finite speed, about 186,000 miles every second. Fast enough to circle the Earth 7.5 times in the time it takes to say the word once, but not infinitely fast. So light from the most distant things has only had 13.8 billion years to travel toward us. Anything farther away than that, its light simply has not arrived yet. We are not seeing the edge of the universe. We are seeing the edge of the part of the universe that has had time to send us a message. There is a subtlety here worth slowing down for, because it surprises people, and it is genuinely strange. You might expect that if the universe is 13.8 billion years old, the farthest we could possibly see is 13.8 billion light-years. But the objects that emitted the oldest light we now receive are presently about 46 billion light-years away, not 13.8. That is not a contradiction. It is simply what expansion does. Space itself has been stretching the entire time the light was traveling, so the distance between us and the source kept growing while the light was in transit. Picture a message written on a long rubber band, and someone slowly pulling the rubber band apart the whole time the message is being carried toward you. The message still arrives, but the place it came from is now much farther away than it was when it was sent, because the road itself lengthened beneath the traveller's feet. So the radius of what we can see is about 46 billion light-years, and the full width is about 93, and all of that is just the part close enough to have reached us. And here is the quiet, important thing that most people never sit with. That boundary, the edge of what we can observe, is not the edge of what exists. It is only the edge of what we can see from here, right now. There is no wall out there. Nothing special happens at that distance. It is not the rim of the world, not a shell, not a barrier. If you could somehow stand at what is, for us, the very edge of the observable universe, you would not find an end. You would find an ordinary patch of space, with galaxies around you in every direction, and a brand new horizon of your own stretching out beyond you, full of things too far away for your light to have reached. The horizon travels with the observer. It is a property of where you are standing and how long the universe has existed, not a property of space itself. Beyond it, given how long the universe has been around and how fast light moves, space almost certainly keeps going. Let that reframing settle before we go on, because it quietly overturns the picture most of us carry without ever noticing we carry it. The night sky does not actually show us the universe. It shows us the inside of a bubble whose size is set by just two things, the speed of light and the age of the cosmos. And that bubble is centered, as far as our own view is concerned, on us. That is not because we are special. Every other point in space sits at the center of its own such bubble, overlapping ours, reaching out into regions we will never see, while ours reaches into regions they will never see. The horizon is not a feature of the universe, it is a feature of the observer. It belongs to wherever you happen to be standing, and to how long there has been a cosmos to look at. So the honest position is not that the universe is 93 billion light-years across. The honest position is that 93 billion light-years is simply as far as light has had time to carry us news, and that the true size of everything is a separate question, one our eyes can never settle, no matter how fine our instruments become. We could build a telescope 1,000 times more powerful than anything we have, and it would not push that boundary outward by a single mile, because the limit was never about seeing clearly. It was about light not yet having arrived. To learn the real size of things, we cannot look harder. We have to reason from the clues the visible part leaves behind, and the first and best of those clues is the shape of space itself. The only real question, the question that decides everything else tonight, is how far. And depending on how you answer that one question, the entire conversation changes. There are really only two possibilities. Either the universe is finite, meaning it has some total size and somewhere, somehow, it ends, or it is infinite, meaning it genuinely goes on forever, in every direction, without end. These are not small alternatives, and they are not a matter of taste. They lead to completely different universes and completely different answers to whether you are alone. If space is finite, we have to understand what that even means, and what could possibly be at the edge of space itself, which turns out to be a stranger problem than it sounds. And if space is infinite, then mathematics has some genuinely unsettling things to say about what must be out there, waiting, whether we can ever see it or not. So before we can ask whether there is another you, we have to ask a more basic question first. What shape is everything? And remarkably, that is not a question we have to guess at. It is a question we can measure. Part 3. The shape of everything. We cannot drive to the edge of the universe to see whether there is one, but we can do something almost as good, and when you first hear it, it sounds like it should be impossible. We can measure the shape of space itself, from the inside, without ever leaving it, and the shape carries a clue about whether space goes on forever. This sounds like poetry, but it is meant completely literally. Space can be curved. The fabric of reality can have a geometry, the same way a sheet of paper or the surface of a planet has a geometry, and that geometry is something we can actually go out and check with instruments. Think about drawing a triangle, because the whole method rests on triangles. On a flat sheet of paper, the three angles of a triangle always add up to exactly 180 degrees. You learn that in school, and on a flat surface it is always true, no matter how you draw the triangle. But now imagine drawing a triangle on the surface of the Earth, a giant one, with one corner at the North Pole and the other two corners far apart down on the equator. Each side runs as straight as it possibly can across the curved surface. When you measure those three angles, they add up to more than 180 degrees. The triangle bulges outward. That extra amount is the signature of a surface that curves back on itself like a sphere. And there is an opposite case too. On a surface shaped like a saddle, curving away from itself in every direction at once, the angles of a triangle add up to less than 180. So just by measuring triangles, without ever rising above the surface to look down on it, you can tell what shape you are standing on. The geometry leaves a fingerprint inside the measurements. We can do exactly this with the universe. The triangles are enormous, drawn across billions of light years, and the way we measure them is by studying the oldest light there is, a faint glow that fills all of space, called the cosmic microwave background. This is light left over from when the universe was only about 380,000 years old, young enough that the whole of it was still a hot fog, too dense and too hot for light to travel freely. When that fog finally cleared, the light it released has been travelling ever since, and it still washes over us from every direction, now cooled by the long expansion of space to just a couple of degrees above absolute zero, about 2.7 degrees on the Kelvin scale. That ancient light carries a pattern, a set of subtle, warmer and cooler patches whose true physical size we can calculate from the physics of that early era. By comparing how large those patches actually were, with how large they appear to us across the whole sky, we are in effect measuring the angles of cosmic triangles drawn across the entire visible universe. If space were curved like a sphere, the patches would look slightly too large. If it were curved like a saddle, they would look slightly too small. If it is flat, they look exactly the size the physics says they should be, with no distortion at all. When we make that measurement, the answer that comes back is quietly astonishing. The universe is flat. Not flat like a tabletop, but flat in the geometric sense. The triangles add up to 180 degrees. The patches are exactly the size they should be, with no bending. The best measurements we have, from the spacecraft that mapped that ancient light, combined with enormous surveys of how galaxies are spread through space, pin the curvature down to within about 0.2% of perfectly flat. As far as our finest instruments can tell, space has essentially no curvature at all on the largest scales, and that flatness is not just a curiosity. It was one of the great puzzles that the theory of the universe's first instant was invented to explain, because a universe that started with even a little curvature should have grown far more curved over time, not less. The fact that it is so precisely flat is a clue in its own right, one we will return to when we reach the engine that may have made the universe so much larger than it looks. It is worth pausing on the other possibility too, the finite one, because it turns out to be stranger than it first sounds. People sometimes imagine a finite universe as a kind of box with walls somewhere far away. But a box raises an immediate problem, which is the obvious question of what lies on the other side of the wall, and that question has no good answer, because any space on the far side would simply mean the universe was larger than the box after all. So a finite universe, if that is what we have, almost certainly has no walls and no edge at all. Instead, it would close gently back on itself, the way the surface of the Earth is finite and yet has no rim, no point where the ground stops and nothingness begins. Walk far enough in one direction and you would eventually arrive back where you started, having circled the whole of space without ever meeting a boundary. That is a real and respected possibility, and a handful of patterns in that ancient light have occasionally been read as faint hints of it, but the measurements, so far, do not demand it. They sit comfortably with a universe that never closes, never turns back, and simply never ends. Here is why that single result matters so much for our question tonight. If the universe is geometrically flat, and if it does not secretly fold back and connect to itself like some closed loop or some more elaborate shape, then a flat space does not curve around and close. It just keeps going, in every direction, without end. A flat, simply connected universe is infinite. Now, we cannot prove with total certainty that space does not fold back on itself in some way too gentle for us to have noticed, and a few careful researchers have looked for exactly that, searching for the telltale repetitions a folded-up universe would leave in the sky. They have not found them, but the door is not slammed shut, so the honest summary of where the science stands is this. The best current understanding points toward a universe that is either genuinely infinite or so enormous that the difference between infinite and merely staggering does not matter for any calculation we could ever do. And the numbers people put on that enormity are themselves hard to take in. Some estimates, built from that observed flatness together with our best models of the universe's first instant, suggest the whole thing could be larger than the part we see by a factor with something like 10 million trillion zeros in it. Not 10 million trillion, a factor with that many zeros. The observable universe, against that backdrop, would be less than a single grain of sand measured against an entire endless shore, and even that comparison flatters the grain of sand. The moment you take that seriously, the moment you allow that space might truly have no end, mathematics steps forward and begins to say something about you, personally, in the room where you are sitting. Because infinity is not just a very large number, it is a different kind of thing entirely, with its own rules, and those rules are about to reach all the way down from the scale of the cosmos to the exact arrangement of atoms that is hearing these words right now. That is where we go next, and it is where the night quietly stops being about astronomy and starts being about you. Part 4. The rule that changes everything. Most people treat infinity as if it were simply a very big number, the biggest number, the place you arrive at if you keep counting and never stop. But infinity does not behave like a large number. It behaves like a different kind of object, and it follows rules that ordinary numbers do not. Those rules sound almost too simple when you first hear them, and then they lead to conclusions that feel impossible while being completely sound. Tonight, everything depends on one of those rules, so let us build it slowly and carefully, with something you already understand, and only then carry it out to the size of the cosmos. Take a fair coin and flip it. The chance of heads is 1/2. If you flip it 10 times, you might get no heads at all, or you might get 10 in a row. Small numbers are unpredictable. If you flip it 1,000 times, you will land near 500 heads, and if you flip it 1,000,000 times, you will land very close to 500,000, because the more you flip, the more the results settle toward the underlying odds. Now, push that all the way, past any number you can picture, to genuinely without end. If you could flip the coin an infinite number of times, you would get heads an infinite number of times. Not approximately, exactly infinitely many. And you would also get tails an infinite number of times. And here is the part that matters most. You would get a run of 100 heads in a row, somewhere in that endless sequence, an infinite number of times. Because a run of 100 heads has a real non-zero chance of happening, however small, and any outcome with a non-zero chance, given infinitely many tries, does not merely probably occur, it occurs. In fact, it occurs infinitely often. That is the rule, and it is worth saying in the plainest words possible. Anything that can happen, given infinite chances, must happen, and must happen again and again without end. The only things that never occur are the things that are truly impossible, the things with exactly zero probability. Everything else is not just possible, it is mandatory. Now we replace the coin with something far larger. Instead of a coin flip, let each trial be a region of space the size of our entire observable universe. Our observable universe, that 93 billion light-year sphere we live inside, is a particular arrangement of matter and energy, atoms sitting in particular places, stars in particular positions, planets on particular orbits, and you, here, in this one specific configuration of particles, having this one specific evening with these specific thoughts. It is staggeringly complicated. But, and this is the crucial word, it is not infinitely complicated. It is made of a finite number of pieces, and that single fact is the key that the rule of infinity turns. Consider how many atoms there are in the observable universe. The number is roughly 10 to the 80th power, which written out is a 1 followed by 80 zeros. That is an enormous quantity, large enough that you could not finish writing the zeros in a lifetime. But it is finite, and a finite number of pieces can only be arranged in a finite number of ways. The number of arrangements is colossal, but it is bounded. There is a ceiling. Physicists sometimes frame this more carefully in terms of quantum states, the total number of genuinely distinct configurations a region this size could possibly be in, taking into account everything physics allows. The estimate for that number is 10 raised to the power of 10 to the 118th. Let that settle for a moment, because it is a strange thing to hold. It is 10 raised to the power of a number that itself already has more than 100 digits. By any human measure, it is a quantity beyond comprehension, and yet, like the count of atoms, it is finite. There is a largest possible number of ways for a chunk of space this size to be arranged, and once nature has used them all, the only thing left to do is repeat. There are no new configurations to invent. There is only the finite catalogue, run again. So put the two ideas together, the way they have been quietly waiting to be put together since the beginning of the night. If space is infinite, and if matter is spread through that infinite space at roughly the same average density we see around us, which is our best current understanding, then there are infinitely many regions the size of our observable universe out there. Infinitely many trials. And each region can only take one of a finite number of configurations. Infinitely many trials, each landing on one of a finite set of outcomes. The rule of infinity then forces the conclusion exactly as it did for the coin. Every possible configuration must occur. Not probably, necessarily, and not once, but infinitely many times over. It helps to sit for a moment with how strongly the mind resists this, because the resistance is itself worth understanding. Everything in your experience insists that you are singular, that there is one of you, and that the idea of an exact duplicate belongs in stories rather than in physics. But notice that the resistance is not an argument. It is a feeling built from a lifetime spent inside a single body in a single place, never once meeting a copy of anything that mattered. The coin does not feel this resistance, which is exactly why the coin is such a patient teacher. We accept without strain that an endless run of coin flips must contain every finite pattern, 100 heads in a row, 1,000, any sequence you could name, each appearing not once, but without end. The only new step tonight is to let the pattern be larger than a string of heads and tails. Let the pattern be a whole region of space, with all its atoms in all their positions. Nothing in the logic changes when the pattern grows that large. What changes is only how personally it lands, because now one of those inevitable patterns is you sitting where you are sitting, thinking what you are thinking. The mind wants to treat that as a wilder claim, a different kind of claim. It is not. It is the very same claim as the coins, carried faithfully and without flinching all the way to its end. This is not a metaphor. This is not a mystical leap or a trick of language. This is arithmetic, the same arithmetic as the coin, performed on a stage that happens to be endless. And one of those finite configurations, one of the arrangements that must occur and recur without end, is the exact configuration that is happening right now in the region around you. Which means that if space truly has no end, there are not just similar places out there. There are places identical to this one, down to the very last particle. The same earth, the same room, the same chair, the same you, with the same heartbeat and the same half-finished thought. I want to flag something before we go on, because a careful listener will already feel an objection forming. You might be thinking that quantum physics, with its built-in randomness, should make perfect copies impossible, that no two regions could ever truly match down to the smallest detail. That is a sharp objection, and we will face it directly, but here is the surprise waiting at the end of it. When you follow the quantum objection all the way through, it does not rescue your uniqueness. It multiplies your copies. We will get there. For now, hold the arithmetic, because it has carried us somewhere remarkable, and it deserves to be felt rather than rushed. So let us go and find that other you. Part 5. The Stranger Who Is You. When I say there is another you, I want to be precise about what that word identical is doing, because the everyday version of the idea is far weaker than the real one. I am not talking about someone who looks like you, or shares your temperament, or has lived a roughly similar life. I am talking about a person whose brain holds the exact same arrangement of cells and connections and electrical states as yours in this instant. A person who has lived the same life, made the same choices, kept the same memories, carries the same small private worries that no one else knows about. A person who, if you could somehow stand beside them, would match you in every physical measurement that could ever be taken, down to the position of every atom in the part of your brain that is processing this sentence. By every test physics knows how to perform, that person is not similar to you. That person is you. And the rule we just built says that in an infinite universe, with the same physics running everywhere, that person is not a possibility. That person is a certainty, and there are infinitely many of them. The physicist Max Tegmark, who has thought about this more carefully than almost anyone, worked out roughly how far away the nearest one should be. His estimate for the closest place where the entire observable universe repeats itself exactly, your nearest cosmic twin embedded in an identical bubble of surroundings, is about 10 to the power of 10 to the 118th meters away. And there is a nearer number too, and it is the one that should give you pause. The closest exact copy of you specifically, the person and not the whole surrounding cosmos, should sit something like 10 to the power of 10 to the 29th meters from here. Keep those two distances separate in your mind, because the difference between them is the difference between copying a single person and copying a whole universe. The copy of you alone is far closer than the copy of everything around you, simply because a person is a smaller pattern to reproduce than an entire cosmos. Neither of those numbers has a comparison that would help you, because no comparison exists for them anywhere in ordinary life. The whole observable universe is only about 10 to the 26th meters across. The distance to your nearest exact copy is so much larger than that the number of zeros in the distance would itself be a number too large to write down inside everything we can see. But here is the thing about an infinite space, and it is the thing that turns these absurd numbers from a curiosity into something that touches you. A distance like that, no matter how monstrous, is finite. And in a space that genuinely has no end, a finite distance is not a barrier to existence. It only means you can never travel there, never see it, never send or receive a single signal across it in the entire lifetime of the cosmos. It does not mean the place is not there. Your twin is there. There is another you, right now, who has just read or heard this exact sentence, and is having the same thought about it that you are having, including, perhaps, this very thought about having the thought. Let me hold that moment open, because it is worth standing inside rather than just being told about. Imagine you could lift off from where you are sitting and travel in a perfectly straight line, out past the moon, past the sun, out beyond the last stars of our galaxy, out past every galaxy our telescopes have ever caught, and keep going, for a distance written as a 1 followed by a tower of zeros no page could hold. You do not slow down. You do not arrive at any wall, because there is no wall. The galaxies keep streaming past, ordinary and uncountable, for longer than the mind can stay focused. And then, somewhere along that impossible line, you reach a region that looks like home, not similar, the same. There is a galaxy arranged exactly like ours, a star exactly like the sun, a pale world, third from that star, with the same coastlines, the same clouds, drifting over the same oceans, the same city, the same street, the same window, with the same light in it. And in the room beyond that window, someone is sitting exactly where you are sitting. They have your face, they have your memories of this morning, the same taste still in their mouth from the same cup. And at this very instant, they are hearing a voice describe a straight line out past the last stars to a room exactly like theirs, where someone is sitting exactly where they are. They feel, as you feel, that they are the original, the real one, the center of the story. There is no way, from inside either room, to tell which of you is which. There is no fact anywhere that makes one of you the true one. You are simply two identical instances of the same person, separated by nothing but distance. Let me be even more exact about what is being claimed, because the word identical is doing heavy lifting, and it is easy to soften it without meaning to. This is not a person who would merely remind you of yourself. This is a person whose every memory matches yours, who carries the same small scar from the same forgotten afternoon, who is, at this instant, partway through the exact thought you are partway through. If you shifted your weight a moment ago, they shifted theirs. If a particular word in this sentence caught at you, the same word caught at them, in the same way, for the same reason. There is no detail small enough to tell you apart, because to differ by even one detail would be to be a different configuration, and we are speaking of the same configuration reproduced exactly. And the strangest part is not that such a person could exist. It is that, in an endless space, such a person must exist, and not one of them, but an unending number, and every single one is, by every measure physics can take, as fully you as the you who is doing the measuring. The word original quietly loses its footing here. None of them came first. None of them is the true one from which the others were stamped. There is simply no fact of the matter about which is the real you, because that question assumes a single original that an infinite universe does not contain. Now, this is the most conservative version of the whole idea, and that is worth saying plainly, because everything we add after this is stranger. This first layer, often called the level 1 multiverse, asks for nothing exotic, no parallel dimensions, no new physics, no quantum strangeness. It asks only that space is large enough, and that the same kind of matter and the same laws continue out past our horizon, the way they continue everywhere we can actually look. And here, a fair person raises the sharpest objection of all. How do we know that matter keeps going past what we can see? Maybe our observable universe is a rare lit island in an otherwise empty darkness. Maybe beyond the horizon there is nothing or something so different that none of this applies. That is an honest question, and we cannot fully answer it, because by definition we cannot see past the horizon to check. But the assumption we make is not arbitrary. Everywhere we can look, the universe is remarkably uniform on large scales. When you average over distances of a few 100 million light years, the spread of galaxies, the structure of matter, the faint glow of that ancient light, all of it looks essentially the same in every direction and at every place we can sample. The universe shows no sign of having a center or an edge or a special region. This sameness has a name, the cosmological principle, and it is the bedrock that modern cosmology is built on. If it holds beyond our horizon, the way it holds everywhere we can see, then matter continues, galaxies continue, stars and worlds continue, and the same laws continue to govern all of it. It is an extension of what we know into what we cannot see, but it is a well-motivated one, supported by every direction we have ever pointed a telescope. There is a second objection, subtler than the first, and it is the one I promised we would face. Even granting infinite space full of matter, doesn't quantum physics, with its genuine randomness, make two regions matching perfectly down to the last detail impossible? It is a real complication, and the honest answer is one of the strange turns of this whole subject. The argument for copies does not depend on hidden, secretly fixed details that randomness could spoil. It depends on the finite number of distinct quantum states a region can occupy, and quantum theory, properly followed, does not reduce the number of U's. If anything, it raises it, because as we will see, quantum physics has its own way of producing copies, one that operates not across enormous distances, but right here, constantly. So the quantum objection, chased to its end, does not return you to being singular. It hands you more company, not less. We will come to that. For now, we have opened only the first door, and already the single self you woke up as this morning has quietly become one of infinitely many. And the version of you sitting in that identical distant room is only the beginning, because the rule that produced an exact copy also produces every version of you that almost was. Part 6. Every life you didn't live. There is a second consequence hiding inside that first layer, and for many people, it lands harder than the perfect copies do. It is not only that there are exact duplicates of you out there, it is that there are all the near misses. Every version of you that could have been, within the laws of physics, is also out there, each of them real, each of them infinitely repeated. Because in an infinite space, every arrangement of matter that can occur does occur, and the identical copies are just one narrow set of arrangements among countless others. All the slightly different ones happen too, and so do the very different ones, as long as the laws of physics allow them. So there is a version of you who made every choice you made, except one. A version who said the other thing in the conversation that you still turn over in your mind late at night. A version who took the job you turned down, or turned down the job you took. A version who woke up 5 minutes later this morning and so missed the small thing that quietly changed the shape of the whole day. There is a version who kept the friendship you let drift, and a version who let drift the friendship you kept. There is a version who became the painter, or the musician, or the traveller, or whatever it was you once thought you might be, before the years pointed you somewhere else, and not one of each, an infinite number of each. The version of you who walked the path you didn't walk is not a single wistful ghost somewhere. They exist countlessly, scattered through the endless reaches of space, and every one of them is as real and as solid as you are, made of the same kind of atoms, governed by the same laws, separated from you only by distance. Follow that just a little further, because it reaches into territory we usually keep closed. If every physically possible version of you is real, then every best version of you is real. Every version who rose to the moment you fell short in, who was patient when you were not, who said the kind thing instead of the sharp one, who made the choice you still wish you had made. They are out there, living those better hours. And they are you, and by the same arithmetic, every worst version of you is also real. Every version who made the choices you are most grateful you did not make, who hurt the people you would never hurt, who became someone you would not want to be. They are out there too, equally real, equally certain that their life is the only one. This is not a reason to feel proud that the good versions exist, or ashamed that the bad ones do, because here is the quiet center of it. You, the one making choices tonight, are not guaranteed to be either the best or the worst version. You are simply the version in this branch, the one who still has the next choice in front of them, unmade. I want to be careful with how this lands, because it is easy to turn it into either despair or false comfort, and it is honestly neither. The point is not that your choices do not matter, because every choice gets made somewhere by someone wearing your face. And the point is not that everything is fine, because the happy version of your life is being lived out there in the dark. The point is quieter, and I think more honest than either of those. The person you might have been is real. Somewhere, separated from you by a distance no word will ever cross, the life you set down is being carried by someone who is you, who picked it up at the fork where you let it go. They are not better than you, and not worse. They are simply the instance who turned left where you turned right. And every one of them, in their own region, feels exactly what you feel. That singular and total sense of being the one real you, the one who made genuine choices, the one whose life is the actual life and not a road untaken. There is something almost unbearable in that, and also something gentle, and the two feelings do not cancel out. They sit side by side, and learning to hold both without collapsing one into the other might be the most honest response there is. The roads you did not take were not erased. They were not lost. They are being walked fully and completely by people who are you, and who will never know you exist, as you will never know them. The grief of a path abandoned, and the strange comfort that the path still exists, are, in an infinite universe, the same fact seen from two sides. You cannot reach those other lives. You cannot trade places with them, or send them word, or learn how their version of the story turned out, or warn them, or thank them. You only get this one, the branch you are standing in, the choices in front of you tonight, the ordinary unfinished evening you are actually in. But you are not the only attempt the universe made at being you. You are one of an endless family of attempts. And this one, the one hearing these words, is the one you get to live. Some people, sitting with this, feel it lighten the weight of their choices, since every choice gets made somewhere, regardless of what they decide. Others feel the exact opposite, that it sharpens the weight, because this branch, this version, is the one they are actually answerable to, the one whose consequences they will actually have to live inside. Both reactions are honest, and the physics does not settle between them, because the physics is not in the business of telling you how to feel about being one of many. What it does say is quieter and harder to argue with. The meaning you find in your life was never built on being the only one who could have lived it. The love between two people is real and particular, even though, somewhere, identical versions of those two people are loving each other in an identical room. The relief of finally solving a hard problem, the taste of a meal shared with someone you trust, the ordinary comfort of a familiar voice in the next room, none of these ever depended on cosmic uniqueness, and none of them lose a single thing when you learn they are happening elsewhere too. We already live this way, in a smaller form, every single day. Right now, somewhere on this one planet, other people are feeling almost exactly what you are feeling, thinking almost exactly what you are thinking, and it has never once made your own version of it less real or less yours. And here is what keeps this from being only a melancholy thought experiment, the thread that pulls us into everything still to come. Everything we have said so far comes only from the first and gentlest layer, the one that asks for nothing but an infinite space and the same physics carrying on out of sight. We have not yet touched the layers that introduce different laws of nature, or the layer that splits reality at every quantum instant, or the layer stranger than all the rest. Each one of those is going to take this same idea, that you are not singular, and push it further, into territory where the copies multiply faster than mere distance could ever manage. So hold this question close, because it runs through the rest of the night. If there can be this many of you from infinite space alone, what happens when the universe turns out to have more than one way of making you? That is the next door. And on the other side of it, even the laws of physics stop being the same from one place to the next. Part 7. The engine that never stops. To understand why the universe might be so unimaginably large that copies of you are not just possible but inevitable, we have to talk about the first sliver of a second after the beginning, and a process called inflation. Not the kind that makes groceries cost more, the cosmological kind. And once you see how it works, the existence of other versions of you stops looking like an exotic add-on and starts looking like a fairly natural consequence of physics we already had good reasons to believe. In the first tiny fraction of a second, before the universe was even a trillionth of a second old, cosmologists think something dramatic happened. Space underwent a burst of expansion that was not merely fast, but exponential. There is a real difference, and it matters. Fast expansion means things get bigger quickly at a steady clip. Exponential expansion means things double, and then the doubled thing doubles, and then that doubles, in equal steps of time, the way money grows under compound interest, except here it was the whole of space, doubling and doubling and doubling again, in a sliver of time, too short for any clock to register. In that instant, space grew by a factor of at least 10 to the 26th, carrying a patch smaller than a single particle up to something around the size of a grapefruit, in less time than it takes light to cross a single atom. The scale of that stretching is almost impossible to hold, and it happened, if it happened, faster than thought, faster than almost any process we know. This idea, first worked out around 1981 and refined by several physicists in the years after, solved a whole list of stubborn puzzles at once, which is usually the sign that a theory is touching something real, rather than merely papering over a gap. It explained why the universe is so flat, the very flatness we measured earlier, because a tiny curved patch stretched by that enormous factor would be pulled smooth. The way the surface of a balloon looks flatter, the more you inflate it. It explained why that ancient background light looks so smooth and even across the entire sky, because regions that now sit on opposite sides of the heavens were once close enough to even out before inflation flung them apart. And it explained why we do not see certain exotic leftover particles that older theories predicted should flood the cosmos, because inflation would have diluted them away to nearly nothing. One mechanism, and a stack of separate mysteries fell into place together. But inflation carries a consequence that most people never hear about, and it is the one that matters for us tonight. Once inflation starts, it is extraordinarily hard to stop everywhere at the same time. The expansion was driven by a kind of energy filling space, and as that energy drains away in any given region, inflation ends there, and ordinary cosmic history takes over, cooling into particles and stars and galaxies, into a universe like ours. But quantum physics keeps jostling that energy, nudging it up here, down there, unpredictably. And in some regions, the jostling keeps the energy high, so inflation does not end there. It keeps going. It even speeds up. The result is that inflation, once begun, never truly stops. It ends in patches, and each patch where it ends becomes something like its own beginning, its own expanding universe with its own history. But in the spaces between those patches, and beyond them, inflation rolls on, endlessly throwing off new patches, new beginnings, new universes, without end. This picture is called eternal inflation, and it is the standard prediction of most of the inflationary models physicists have worked with, not a rare or fringe variant. In it, what we call the universe, the entire 93 billion light-year sphere, and everything past our horizon, is one patch, one bubble of finished inflation, floating in a far larger structure that is still inflating, still budding off new bubbles in every direction. We live inside one bubble. And the larger structure is constantly producing more, and has been, perhaps, for as long as it has existed. Let me hold this one open the way we held the last, because it is worth seeing and not just hearing. Imagine pulling back, not just past the galaxies, but back until our entire observable universe. That whole staggering sphere we have spent the night measuring is a single bubble, one bead of stillness, in an enormous churning expanse that is everywhere inflating around it. From out here, beyond cosmic time, you watch new bubbles form. One brightens into being over there, and ignites its own beginning, its own version of what we would call a Big Bang, its own first light. Another forms far below, and another off to the side, and another, each one detaching from the inflating sea, and starting its own history, its own slow cooling, its own first generation of stars. They switch on across the dark like windows, lighting up in a city that has no edge and no last street, faster than they could ever be counted, and the expanse between them never settles, never runs out, never stops making more. You are floating above a process that has no off switch and no boundary, watching universes being born the way foam keeps forming on a moving current, endlessly, indifferently, forever. And not one of those bubbles knows about any of the others. Now here is the part that turns this into a new layer of copies, rather than just a bigger version of the old one. When inflation ends in a given bubble, the details of how it ends can differ. The energy can settle into different stable configurations, and each configuration corresponds to a different set of physical constants, the numbers that set the strengths of the forces, the masses of the particles, the basic terms of physics. In our leading attempt at a theory of everything, string theory, there may be something like 10 to the 500th power distinct ways for the hidden structure of space to settle, each one yielding a different version of physics. That enormous menu of possible universes means different bubbles could run on genuinely different laws. Some would have no stable atoms at all, because the forces do not balance and matter cannot hold together. Some would have no stars, because gravity is too strong or too weak. Some would collapse back into nothing almost as soon as they began, and some would fly apart too fast for matter to ever gather into anything. Only a narrow slice of the possibilities would land on the delicate set of laws that allow galaxies and chemistry and the slow, patient assembly of something that can sit in a room and wonder about itself. This is the Level 2 multiverse, and it raises an obvious and uncomfortable question. If most possible universes are hostile to life, why do we find ourselves in one that is not? The answer is a piece of reasoning called the anthropic principle, named in 1973, and it sounds almost circular until you feel its real force. We observe a universe with the right conditions for us, not because those conditions were arranged for us, but because we could only ever exist to observe a universe that allowed us in the first place. The hostile universes are out there too. There is simply no one inside them to notice their emptiness. There is a famous case where this reasoning actually predicted something real, and it is worth telling because it is the closest this whole subject comes to a testable success. The energy of empty space, the so-called cosmological constant, is measured to be absurdly small, far smaller than our theories of particle physics say it should be, off by something like 10 to the 120th power, which is one of the worst mismatches between theory and observation in all of physics. And yet, back in 1987, before its value was even known, the physicist Steven Weinberg reasoned that if this energy were much larger, galaxies could never have formed, so any universe containing observers would have to have a small one. He predicted it would turn out small but not zero. About a decade later, it was measured, and it was small, and it was not zero, sitting comfortably inside the window he had drawn. That is not proof of a multiverse, but it is the kind of quiet success that keeps serious people taking the idea seriously. And it leaves us with 2 layers of copies already, one from infinite space, one from endless bubbles, and we still have not reached the strangest layer, the one that does not live far away at all, but right here, in this room, at every passing instant. Part 8. The coin in the air. The next layer of this does not require the universe to be infinite, or inflation to be eternal, or any bubble but our own. It operates right here, at every point in space, at every moment, inside the atoms of your own body. It comes from quantum mechanics, our most precisely tested theory of how reality works at the smallest scales, and it is where the idea of countless versions of you stops being about distant regions of space and becomes something happening continuously, here, now, to you as you listen. Quantum mechanics has been tested more exactly than any other theory in the history of science. Some of its predictions match experiment to about 1 part in a trillion, which is like measuring the distance across an entire continent and being off by less than the width of a single hair. We trust it completely as a tool, and yet, from the very beginning, it has carried a strange, unfinished question at its center, one that has never gone away. The mathematics of quantum mechanics does not describe a particle as being in one definite place with one definite set of properties. It describes it as a spread of possibilities, all present at once, a wave that assigns a likelihood to every outcome a measurement could have. An electron is not simply here or there. It is both here and there at the same time, a smear of possibilities, until the moment something measures it. And then, when we look, we find it in just one place, with one definite value. The spread of possibilities appears to snap down to a single outcome the instant it is observed. The trouble is that the equations themselves do not contain that snap. Left alone, the mathematics says the wave of possibilities should just keep flowing along smoothly and predictably, branching and spreading, never collapsing to one answer. The collapse was something physicists added by hand, a rule bolted on from outside that said, when a measurement happens, pick one outcome with these particular odds. For decades, the working attitude among physicists was, roughly, do not worry about what it means. Just use the rule to calculate, because the calculations match the experiments perfectly. This pragmatic shrug even got a nickname, the instruction to stop asking and simply compute. But the question never actually went away, because it is a strange thing to build your most successful theory on a step you cannot explain. Why does a theory that describes many possibilities only ever show us one? What is a measurement, exactly, that it alone can trigger this collapse? And when, precisely, does it happen? In 1957, a graduate student named Hugh Everett offered an answer that was largely ignored at first and is now taken seriously by a great many physicists. What if there is no snap at all? What if the equations are simply telling the truth and the wave of possibilities never collapses? What if, instead, every time a quantum system interacts with the wider world in a way that could distinguish between its possibilities, reality itself branches? Every outcome happens. Each one plays out in its own branch of reality, and the branches, once separated, can no longer touch or influence one another. From inside any single branch, the others are completely invisible, gone, as good as unreal. But in the full picture, the whole, unbroken wave, every branch is equally real. This is the many worlds interpretation, and what it implies about you is the part that takes the breath away. Your brain is a physical system, and physical systems are built on quantum events. Every time a particle in your body could go one way or another, every time a process in your cells could tip toward one outcome or another, the wave branches and both outcomes occur. This is not happening occasionally in special laboratory conditions. It is happening constantly, uncountably, in every cell of you, in every cubic inch of the room, in every instant. So at every one of those forks, a version of you goes one way, and a version of you goes the other, and from that moment on, those two versions live in branches that can never communicate. The number of branches grows at a rate that defeats any ordinary description, a number closer to the unbroken infinity of the points on a line than to any number you could reach by counting. And in every single one of those branches is a complete, fully real version of you, living that branch as the entire and only reality. Stay with one ordinary moment of this, because it is far easier to feel than to summarize. Picture a coin, flipped, turning over and over in the air. As it spins, the outcome is still a wave of both possibilities, heads and tails together, unresolved. And in the many worlds picture, you, the person watching it, are about to become two people. In one branch, the coin will land heads, and there will be a version of you who sees heads. In another branch, it lands tails, and a version of you sees tails. Both of them remember being you, 1 second ago, watching the coin go up into the air. Both of them are completely you, with everything that means, and neither of them feels anything strange. The one who sees heads simply sees heads, and thinks, of course, it landed heads, that is what happened. The one who sees tails simply sees tails, and thinks exactly the same thing about tails. There is no jolt, no sense of splitting, no moment where either of them feels reality divide beneath them. You do not experience the branching at all. You only ever find yourself in one branch, certain it was the only branch there ever was. And right now, as the coin hangs at the very top of its arc, you are, in the most literal physical sense the theory can mean, 1 instant away from becoming two people who will live out the rest of their lives, never meeting, never knowing, each certain they are the only one. Try to take in the rate at which this is supposed to be happening, because the sheer scale of it is part of what makes it so hard to hold in the mind. Quantum events are not rare, special occurrences. They are the constant background texture of physical reality, occurring beyond any counting in every cell of your body, in every patch of air in the room around you, in every fraction of every second. So the branching is not an occasional fork at the great turning points of your life. It is a continuous, blurring multiplication, the number of branches climbing every second by an amount that would exhaust any number you could ever write down. And in every one of those branches, a version of you simply carries on, experiencing a single, smooth, and unbroken reality, noticing nothing unusual. That is the part that most defeats the imagination. Not that the branches are many, but that you never feel the splitting, not once, not ever, in any branch. From the inside, your life is one continuous thread, seamless and singular, and it always will be, in every branch, for every version of you that there is. The multiplication is total, and the experience of it is nothing at all. You are being divided endlessly in every instant, and it feels precisely like being one person, living one quiet life. Why do so many physicists, despite how wild this sounds, find this the most natural reading of the theory? Because the alternatives all carry their own troubles, and once you line them up, many worlds starts to look less extravagant than it first seems. The version that says the wave collapses when observed has never managed to define what counts as an observation, or what makes a measuring device special, or when exactly the collapse occurs. Another respected version keeps the particles always definite, but has to add invisible guiding machinery that sits awkwardly with the rest of physics. Each repair introduces its own loose threads. Many worlds, by contrast, asks for nothing extra at all. It simply takes the equations at their word and refuses to add a collapse that was never written in them. And there is a process called decoherence, worked out starting around 1970, that explains why the branches stop interacting almost the instant they form, why you can never feel the other outcomes or send a message across to them, because the moment a quantum difference spreads into the wider world, it becomes effectively impossible to reverse. So, whether or not many worlds is finally correct, and that remains genuinely open, it leaves us with a third kind of copy, not waiting across an enormous distance, but peeling away from you constantly, here, in this chair, with every quantum flicker in your body. And that forces a question we have been circling all night, which we now have to face directly. If there are this many of you, what does it actually feel like to be one of them? The answer is the strangest ordinary thing in the whole story. Part 9. Real and out of reach. Here is something that does not get said often enough about all of this, and it is the key to why the countless copies do not feel like anything at all from the inside. Every version of you, in every distant region of infinite space, and in every branch of the quantum wave, experiences their own life as the only one. Each of them feels the same unbroken sense of being a single person with a single past. Each of them is just as certain as you are, that their choices are their own, that their experiences are uniquely theirs, that there is one of them and only one, and from inside their branch, from inside their region, they are completely right. They never experience the splitting, or the duplication, or the company. They experience only their own thread, lit up as the whole of reality, exactly as you experience yours. This is the thing that makes the many worlds picture feel so strange and, at the same time, so oddly calm. When the coin lands, the version who sees heads does not sense the version who sees tails. There is no leakage between them, no faint awareness of the road not taken, no shadow of the other outcome. Decoherence makes the branches independent almost instantly, and from then on each is sealed off from the others, opaque, complete in itself. The same is true across infinite space. Your cosmic twin is not somewhere you can feel, not a presence at the edge of awareness. They are real, made of the same matter, running the same life, and there is no thread of awareness connecting you, no shared point of view, nothing whatsoever that passes between you. Each instance is a closed world. Each one is, to itself, the only one there is. And this is where I have to say the hardest part of the whole night plainly, because it would be dishonest to make this sound only wondrous. Your other selves are real, and they are completely beyond your reach. Not in some other dimension, not in a separate reality you might someday learn to cross into. They are in this universe, made of this kind of matter, obeying these same laws, separated from you by nothing more exotic than distance, or by the thin and total seal between one quantum branch and the next. And yet that nothing more than distance is a distance no signal will ever cross in the entire life of the cosmos. That thin seal between branches is one that no message, no influence, no faint hello will ever pass through, not in principle, not ever. They are as real as you are. They are, in the fullest physical sense the universe allows, you, and you will never know each other. You will never reach them, or comfort them, or be comforted by them, or learn how their version of the story turned out. They are real, and they are unreachable, and both of those things are true at the very same time. There is a loneliness in that, and there is also a strange dignity, and I do not think either should be smoothed away to make it easier. The version of you who got everything right cannot reach back across that gap and help the version of you who is struggling tonight. The version who finally found peace cannot send any of it to the one who has not. The version who is loved exactly as they wish to be cannot lend that to the version who is lonely. Each instance lives in its own sealed branch, with only what it has, making its way with the choices in front of it, and no help from any of the others. The enormous family of you that physics points to does not gather. It does not pool its wisdom, or share its luck, or hold a single one of its members up when they fall. Every single member of it is alone in exactly the way you are alone, and alive in exactly the way you are alive, and certain, as you are certain, that their life is the real one and the only one. It is worth resting in that loneliness for a moment, rather than hurrying past it, because it is one of the truest things this whole picture asks of us to carry. You are surrounded, in the fullest sense the universe allows, by yourself, by every version you might have been, every version who got it right, every version still struggling tonight, the way you might be struggling tonight. They are real, and they are near in number beyond counting, and not one of them can reach you, and you cannot reach a single one of them. It is the most crowded solitude that could possibly exist. And yet I do not think the right response to it is despair, because the very fact that seals you off is the same fact that makes this branch wholly your own. No other version is living your life for you or in your place. The choices in front of you tonight are genuinely yours to make, in this branch, with these consequences, and no copy in any distant region or any neighbouring branch can make them for you, or take them from you, or spare you them. The company you cannot reach does not diminish you. It does something closer to the opposite. It places you, precisely and unrepeatably, here. This raises a question that troubles a lot of people when they first sit with the many worlds picture, and it deserves a direct answer, because it sounds at first as if it should drain all the meaning out of choosing anything. If every outcome of every decision happens in some branch, if the good choice and the bad choice are both made by some version of you, then does your choice matter at all? Here is the honest reply. Even in this picture, your choices have consequences, and they have them in exactly the way that matters to you. When you face a decision, the branches that grow out of it depend on what you decide. The branch in which you chose carefully carries the results of that care. The branch in which you chose poorly carries the results of that. And you, the one standing at the fork right now, are about to become the version who lives in one of those branches. You want to be the version on the better path. That wanting is real, and the choice is real, and it shapes which branch you will find yourself inside. There is even a precise side to this. The different outcomes do not all carry equal weight. Quantum mechanics assigns each branch a measure, a kind of thickness, and rational behavior is to act as if you are steering toward the outcomes with the most weight, which turns out to be exactly the same sensible behavior you would follow if you believed in a single, ordinary world where probabilities are real. So the practical truth is steady and reassuring. Your choices still matter. They still determine the branch you will live in and remember. The fact that other versions of you walk other branches does not thin the reality of your choice, any more than the fact that other people are living other lives thins the reality of yours. We are not finished, though, because so far, everything we have said quietly assumes that you are not being deceived, that your memories are true, that the universe you remember actually happened. There is a possibility lurking underneath all of this that threatens even that, and we have to look straight at it before we can come home. Part 10. The mind that wasn't supposed to be here. There is a possibility built into the combination of a huge universe and the laws of heat and disorder that is genuinely one of the most unsettling ideas in modern physics. And most people, even people who have heard of parallel universes, have never come across it. It is called the Boltzmann brain problem, and it threatens something we have quietly leaned on all night, the assumption that your memories are real and the universe you remember actually happened. It starts with the work of a physicist named Ludwig Boltzmann, who in the late 1800s gave us much of our understanding of entropy, the measure of disorder. His insight was that disorder is really about probability, about counting. There are only a few ways for a set of things to be neatly ordered, and overwhelmingly many ways for them to be jumbled, so as time passes, systems drift toward the jumbled states simply because there are so many more of them to drift into. A glass of water with ice in it is an ordered, low disorder arrangement. Leave it on the table, and the ice melts into a uniform glass of cool water, because the disordered arrangement is so much more probable that the ordered one cannot hold. This is the deepest meaning of the famous law that disorder always increases. It is not a command. It is a matter of odds, of there being vastly more ways to be messy than to be tidy. But Boltzmann understood something subtle and strange that hides inside that. The drift toward disorder is only overwhelmingly probable, not absolutely required. If you waited long enough, fantastically, unthinkably long, random motion could in principle reassemble the ice cube from the warm water, every molecule happening to wander back into place. The waiting time would be longer than the current age of the universe by a factor with no name, but it is not forbidden, and in an endless stretch of time, even the wildly improbable does not merely become possible. It becomes certain to happen, again and again. Now carry that into the far future and watch where it leads. Picture the universe enormously old, long after the last stars have burned out, after most structure has dissolved into a thin, cold, nearly uniform haze with almost nothing happening in it. Even there, random fluctuations never stop entirely. Particles drift, and occasionally, by pure chance, a few of them clump into something briefly ordered. Almost always, something tiny and trivial. But once in an unthinkable while, across enough emptiness and enough time, a fluctuation could assemble something complicated. And here is the disturbing step, the one that has cost cosmologists real effort to think through. On a long enough timeline, a random fluctuation could assemble something as complicated as a working human brain, complete with a full set of memories and the vivid, seamless feeling of being a person with an entire past, flickering into existence out of the haze, having an experience for a moment, and then dissolving back into the dark. Its memories would be false, conjured whole by the fluctuation rather than lived. But from the inside, it could not possibly tell the difference. It would feel exactly like being you, right now, certain of a childhood, a name, a life, a whole world, none of which ever happened. The troubling question physicists raised, beginning in the early 2000s, is a question of counting, the same kind of counting Boltzmann started with. In a universe that lasts long enough, how many of these fluctuation minds would appear, compared to ordinary minds that grew up the slow way, in a real history, on a real planet, through billions of years of patient assembly? And for some models of the universe, the unsettling answer is that the fluctuation minds would outnumber the real ones by an overwhelming margin. If that were true, then the most likely explanation for any single conscious moment, including this very one, including yours, would be that you are one of those fluctuations, that your memories are noise, that the world you think you remember never existed, and you are a momentary pattern in an empty cosmos already beginning to come apart. Now, before that settles too heavily, let me tell you why most physicists are confident that we are not those fluctuation minds, because the resolution is itself a beautiful piece of reasoning, and it steadies the floor again. A fluctuation that produced just a single brain with false memories would be enormously, astronomically more likely than a fluctuation that produced an entire consistent universe, with 13.8 billion years of coherent history, working physics in every direction, and a sky full of galaxies that all agree with one another. Order is expensive. In the currency of probability, and a whole self-consistent universe is far more order than a single lonely brain. So if you really were a random fluctuation, you would almost certainly find yourself with a few scrambled impressions and nothing else, not seated inside an enormous, lawful, self-consistent cosmos that holds together perfectly everywhere you point a telescope, where every measurement agrees with every other. The simple fact that we do find ourselves inside exactly such a cosmos, one whose details we can check against each other endlessly and find consistent, is strong evidence that we got here the slow, real way, and not as a flicker in the void. What makes this more than a ghost story is that it grows out of the very same counting we have leaned on all night, only pointed at the far future instead of at distant space. Order is rare and disorder is common, not because the universe has a preference for mess, but because there are so many more ways to be jumbled than to be neatly arranged. A working brain is an exquisitely arranged thing, so a fluctuation that happened to build one would be staggeringly unlikely in any ordinary stretch of time. But the far future of the universe is not an ordinary stretch of time. If the cosmos lasts forever, or near enough to forever, then staggeringly unlikely is no longer the end of the story, because we already know what infinite chances do to anything with a probability above zero. They turn it from rare into certain, and from certain into endless. So the genuinely troubling part is not that a single fluctuation brain might form once. It is that, given unlimited time, an unlimited number of them must form, and the only question left is whether they would come to outnumber the minds that grew up the slow and ordinary way on real worlds with real pasts, and that turns out to be a question of weighing one infinity against another, which, as we are about to see, is exactly the place where this entire subject becomes most treacherous. And this is where the Boltzmann brain stops being only a horror and quietly becomes a tool, one of the more elegant turns in the whole subject. Physicists now use it as a kind of test for their theories. If a proposed model of the universe predicts that fluctuation minds should outnumber real ones, that is treated as a serious mark against the model, almost a disqualification. Because a universe that mostly produces deceived minds would be a universe in which you could not trust any chain of reasoning at all, including the reasoning that built the model in the first place. The theory would soar off the branch it was sitting on, so the same wild logic that gave us copies of you across infinite space also hands us a way to rule out theories that reach too far. And the lesson underneath it is the one that has run through this entire night, stated now in its sharpest form. In a universe large enough, Improbable things do not merely become possible, they become inevitable. The only real question is which improbable things, and that depends entirely on the physics. We have one door left to open, and it is the strangest of all, and then we can finally turn around and come home, and ask what every bit of this means for the one person actually sitting here tonight. Part 11. The Last Door and its Limits. The 3 layers we have walked through so far all share something quietly in common. They are all physical. The first stretches our kind of reality farther across space. The second produces other regions running on different constants. The third branches our reality at every quantum event. But in every one of those cases, there is a physical world running on mathematics, and the mathematics is understood to describe the world, to be about something. The last layer asks a question that sounds more like philosophy until you sit with how seriously it is actually meant. What if the mathematics is not the description of the world? What if the mathematics is the world? This is the idea, proposed by the physicist Max Tegmark, that every mathematical structure which is fully self-consistent exists physically in the same sense ours does. Not just our particular equations, and not just nearby variations on them, but every possible consistent mathematical structure, every set of relationships that does not contradict itself. Most of them would be simple, barely anything at all, a handful of relationships and nothing more. Some would be intricate enough to contain time and matter and complexity. And among those, some would be elaborate enough to contain structures that process information, that model their surroundings, that are, in some real sense, observers, aware of themselves. And among those, some would be this universe, with these exact laws, with you somewhere inside them, listening to this. In this picture, our universe is not singled out by having some special extra ingredient called physical existence sprinkled on top of the math. There is no extra ingredient. To exist and to be a self-consistent mathematical structure are, in this view, simply the same thing said 2 ways. The reason a careful physicist would even entertain this, and not as mysticism but as a serious proposal, comes from a pattern that everyone who studies physics notices eventually. When we describe the universe at its most fundamental level, we describe it with mathematics, and the further down we go, the less there seems to be underneath the math. We do not reach a floor of solid stuff that the equations are merely about. We reach more equations, more relationships, more structure. Reality, examined closely enough, looks mathematical all the way down, with no obvious bottom of ordinary matter holding it up. And if that is so, the question follows on its own. Why would our particular mathematical structure be the only one granted real existence, while all the others remain merely abstract, unrealized possibilities? That asymmetry would itself demand an explanation, a reason why this structure and not the others. This last layer answers by removing the asymmetry entirely. All consistent structures exist. We find ourselves in this one only because it is one of the ones capable of holding something like us. It even offers a clean answer to one of the oldest puzzles in science, the question of why the universe has the particular laws it has, rather than some others. The answer becomes, it did not have to have any particular laws. It only had to have some self-consistent form, and we are in this one because this one can contain minds that ask the question. Now, I have to be just as honest about the limits of all this as I have been about its reach, because that honesty is the whole reason any of it is worth your trust. Not all of these layers stand on equal ground, and a careful person should hold them with very different degrees of confidence. So let me lay out the ladder plainly, from solid to speculative. What we actually know, with strong evidence, is a short and firm list. The universe is about 13.8 billion years old. The observable part is about 93 billion light-years across. Space is flat as far as we can measure, to within a fraction of a percent. The early universe went through a burst of rapid expansion that left specific fingerprints we can still read in that ancient background light. Quantum mechanics is correct to staggering precision, and quantum systems genuinely do exist as spreads of possibility before they are measured. That is the firm ground, and none of tonight rests on sand below that line. Above it sits what we have strong reasons to believe, but cannot directly confirm, that inflation, once started, keeps generating new regions, and that space extends far past what we can see with the same physics holding out there. Above that sits the reasonable but less certain, the menu of possible universes from string theory, and the many worlds reading of quantum mechanics being not merely a valid interpretation, but the correct one. And at the very top floor sits the most speculative idea of all, that every mathematical structure exists. The copies of you are most secure at the first level, which asks only for an infinite space and the same physics carrying on. They grow less certain, not more, as we climb the ladder, and an honest mind should feel that difference in its bones. There are two genuine cracks worth naming out loud, because the people who study this take them seriously, and so should we. The first is called the measure problem. When everything that can happen happens infinitely often, comparing how common one outcome is against another becomes mathematically slippery, because you are effectively dividing one infinity by another, and the answer depends on how you choose to do the counting. Different reasonable ways of counting give different probabilities. Without a single agreed way to count, the multiverse struggles to make sharp, checkable predictions, and that is a real weakness, not a small technicality to be waved away. It helps to see why comparing infinities is not merely hard, but genuinely ambiguous, and a small example makes it vivid. Ask whether there are more whole numbers or more even numbers. In one obvious sense, there are twice as many whole numbers, since the evens are only half of them, the odds being the other half. But in another, equally valid sense, you compare every whole number with its own double, 1 with 2, 2 with 4, 3 with 6, onward forever, never running out and never missing a single one, which says the two collections are exactly the same size. Both answers are correct. The honest reply to how many is that it depends entirely on how you have chosen to count. Now carry that into a universe where every outcome happens infinitely often. To ask how likely you are to be one kind of observer rather than another, you have to compare how many of each there are, and you find yourself weighing two endless collections whose ratio quietly shifts depending on the counting rule you reach for. Without a single principled way to do the counting, the prediction slips through your fingers every time you try to close your hand on it. This is not a small footnote to the theory. It is one of the central unsolved problems in turning any of this into science that can actually be tested. The second crack is the one that some of the most respected physicists alive consider the most serious of all. It is the question of whether any of this is science at all. A theory earns its place in science by making predictions we can go out and test, but copies of you in distant regions, or in other bubbles, or in other branches, can never be observed from here. No signal will ever cross to confirm them. In 2014, the physicists George Ellis and Joe Silk wrote a pointed essay in the journal Nature, warning that when physicists begin defending theories whose central claims can never be tested, they risk eroding the very thing that makes physics trustworthy in the first place. Others, the physicist Sean Carroll among them, push back, arguing that a theory can be well supported indirectly even when some of its consequences are forever out of reach. The way we reason with great confidence about the inside of a black hole that we can never observe from outside and live to report. This is not a settled fight with a winner. It is a live disagreement among brilliant people, happening right now at the highest levels of the field, and the fact that it is happening at all is itself worth noticing. These ideas are not fringe. They sit at the center of the most active questions in theoretical physics, and what is being argued about is not whether they deserve to be taken seriously, but how seriously, and how on earth we could ever know. It is worth being honest about how unusual this situation is in the whole history of science, because it is not the familiar story of a good theory simply waiting for a better telescope. The trouble with the higher layers is not that our instruments are not yet sharp enough. It is that, if these ideas are right, the things they predict sit forever beyond any instrument anyone could ever build, sealed away from us by distance or by the walls between branches. That is genuinely new ground, and thoughtful people read it in opposite directions. To some, a claim that can never, even in principle, be checked has quietly stopped being physics and become something closer to philosophy, wearing the vocabulary of physics. To others, those same claims earn their place precisely because they fall out of theories we already trust, for separate, testable reasons. The way the inside of a black hole follows, inevitably from a theory we can test thoroughly from the outside, even though no one will ever cross the threshold and send back a report. Both of those readings are held by careful, serious people, and neither side is being careless or foolish. The disagreement is not really about whether the universe is strange. Almost everyone now agrees that it is. The disagreement is about what we are permitted to say we know and how we could ever come to know it, when the evidence, by its own nature, can never arrive. There is one more turn worth taking before we come home, because we have spoken almost entirely about space and barely at all about time. And time changes the picture too. The universe is about 13.8 billion years old, but its future is far longer than its past. Long after the last ordinary stars have died, the cosmos rolls on through age after age, into a long twilight of cooling embers and slowly evaporating remains, until even the largest dark giants at the centers of galaxies fade away over something like 10 to the 100th power years, a span so long it has its own name, a Google. And if inflation is eternal, then all through that unthinkable stretch, new bubbles keep being born, new beginnings keep igniting, new histories keep starting their own clocks. So the copies of you are not only spread across space, they are spread across time in universes that have not yet begun, that will cool and form stars and worlds, and, somewhere, the same delicate pattern again, long after this one has gone cold. You are not only one instant scattered across an endless space, you are one moment in an endless making, a process of creation that did not happen once and stop, but that may be happening still and may never stop. And with that, with the honesty about what we know and the recognition that the making has no clear end, we can finally turn back from the edge of the cosmos and ask the question this was all really about. What does any of it mean for you, the one here, tonight, in this single branch, in this single room? Part 12. You, again. We have travelled a long way out, so let us come all the way back down to the room you are actually in and ask the question underneath all the others, the one that is hardest to phrase, because we usually leave it carefully alone. Not, who are you? What are you? Most of us carry an unspoken answer to that, so automatic we never examine it. You are your memories, your personality, the unbroken thread of experience that started in one body on one day and has continued ever since. The same single you all the way through. That thread, that sense of being one continuous person moving through time, is what we usually mean when we say ourselves. But everything we have looked at tonight presses on that answer until it begins to give way. Consider what the physics actually describes when it describes you. It describes a pattern, a specific, intricate, temporary arrangement of matter that takes in information, models the world and itself, makes predictions, and has experience, whatever that turns out to be. Not a fixed substance, but a pattern that persists by holding its shape while its material flows through it. The atoms in you now are not the atoms that were in you years ago. Your cells continually rebuild their parts, your connections strengthen and weaken, the matter that makes you up is replaced and replaced again, and still you persist, because what persists was never the stuff. It was the pattern in the stuff. And a pattern, unlike a unique object, is exactly the kind of thing that can be repeated. It can appear in another region of space. It can branch into two. It can be instantiated wherever the conditions allow. The continuity you feel is completely real from the inside, but it is not a fixed fact of the universe that singles you out as the one true original. There is no original. A copy implies an original, and there is none of that here. There are only instances of a pattern, each one whole, each one complete, each one fully itself. Philosophers reached the edge of this long before physics did, coming at it from the side of pure reasoning. Derek Parfit, in 1984, argued patiently that personal identity is not the simple, all-or-nothing thing we assume it to be. What matters, he said, is not some pure metaphysical fact of being the very same person, but the continuity and connectedness of mental life. And that comes in degrees, and can branch, and is not the solid anchor we imagine it to be. He used the example of stepping into a machine that scans every atom of you, records it, destroys the original, and builds a perfect copy from fresh atoms somewhere else. Is the person who steps out you, or a stranger who merely believes they are you? Most people feel sure that something has been lost, that the original died and a copy walked away. But when pressed to say exactly what was lost, they struggle, because if the pattern is perfectly preserved, it is not clear what the missing thing could even be. And notice how close this comes to something you do every night. When you fall into the deepest sleep, your stream of consciousness goes quiet, breaks, becomes something not continuous with your waking mind, and yet you wake in the morning feeling like you, untroubled, never imagining that the person who woke is a copy and the one who fell asleep is gone. The old puzzle of the ship that has every plank replaced over the years until none of the original wood remains, and the question of whether it is still the same ship turns out to be the very question of what you are. And it has never had a clean answer in thousands of years of asking. Traditions far older than physics arrived in this same territory too, by entirely different roads. The idea that the self is a process rather than a fixed essence, a pattern rather than a thing, runs through Buddhist thought, which speaks of the self not as a solid core, but as a flow of events that gives rise to the feeling of a self, without there being a fixed self underneath. It runs through the Stoics, who counseled holding loosely to the particular arrangement, the specific body and history, and identifying instead with the capacity for reason and character that any version of you would carry. I am not saying physics has confirmed any philosophy or any faith. They came by completely different paths, and they answer to different methods, and physics is not their judge or their successor. But it is worth noticing and sitting with when honest inquiry, starting from completely separate places, keeps arriving at the same quiet conclusion. The self is more fluid, more pattern, and less fixed substance than it feels from the inside. There is a kind of company in that, across centuries and cultures and methods, and physics is only the newest voice to join a very old conversation. There is something gently self-referential happening right now too, that is worth naming, because it makes all of this less abstract. You are a conscious pattern, learning, in this moment, about the possibility that you exist in countless copies, and that learning is itself a physical process. It is changing the state of your brain as you take it in, strengthening some connections, loosening others, updating your picture of the world and your place in it, which means the you who finishes this is, in a small but genuine way, a different pattern from the you who began it. And in the many worlds picture, as you processed each idea tonight, the quantum events in your brain were branching, so that there are now versions of you who found this clarifying, and versions who found it unconvincing, versions who will carry it for years, and versions who will let it fade by morning, all of them real, all of them branching off from the single you who started listening. Every piece of understanding that passes into a mind changes that mind, and through it, in some small way, the world. You are a node in a network of minds that, if any of tonight is right, extends not only across everyone alive, but across every instance of every mind that has ever turned these questions over, in every branch and every region where they exist. Let me return now the phrase I asked you to hold at the very beginning. The room is the same, but it isn't anymore. That is exactly where we have arrived, except the room is no longer a room. It is your whole life, your sense of who and what you are, the single thread you have always assumed you were. None of the substance of it has changed tonight. Your memories are still yours. The people you love are still exactly who they are. This evening is still this evening, with whatever is in it. Nothing has been taken from the actual texture of your life. What has changed is only the backdrop, the understanding of how large and how strange the stage is on which your one ordinary life is being lived. And that is not a loss. We have done this before, as a species, and survived it with our wonder not just intact, but enlarged. We once believed the sun was the single center of all things, and then we learned it is one of a few 100 billion stars in our galaxy, and our galaxy one of hundreds of billions, perhaps trillions more, and that there are something like 200 sextillion stars out there, a 2 followed by 23 zeros. Did the sunrise become less beautiful when we learnt the sun was not unique? It did not. If anything, knowing what a star truly is, makes the light on your face in the morning more astonishing, not less. Let that be the last place we stand together for a moment, because it gathers the whole night into a single, ordinary scene. Picture a sunrise. You are outside, early, and the light comes up over the edge of the world, the way it has on every morning of your life, and it falls warm across your face. And now you know what you are feeling. You are feeling the light of one star among 200 sextillion, and at this very instant, that same kind of sunrise is breaking across countless worlds throughout the galaxy, and across countless versions of this same world, scattered through an endless universe. And in some of them, someone with your face is standing exactly like this, eyes closed, feeling exactly this warmth, thinking very nearly this thought. And none of that makes the warmth on your skin 1 degree less real, or 1 degree less yours. The abundance does not thin the experience, it widens it. The you standing in that light was always abundant, made of atoms that were forged inside stars, which died before the sun was born. Atoms gathered up and arranged into a pattern intricate enough to stand in the morning and recognize where it came from. So is this terrifying. That was the word we started with, and after all of it, the word deserves an honest answer. When you first feel the loss of being singular, it can seem like the loss of something that truly mattered. But look closely at what is actually being taken from you. Not your experiences, not the people you love, not this branch of the story, the one you are actually living right now. All of that stays, exactly as real and present and vivid as it ever was. What is being taken is only the illusion of a kind of uniqueness that was never really there to begin with. And what is being offered in its place is a connection to the full scope of what exists and the understanding that the plain laws of nature, faithfully followed, produce you. Not because nature was aiming at you, not because you were singled out or chosen, but because the same ordinary rules that make the stars and the planets and the oceans and the slow emergence of life also make somewhere, inevitably, a pattern complex enough to wonder about itself. In an infinite universe, that was always going to happen. That it happened here, in this branch, in this version, as the one hearing these words right now, is not luck. It is arithmetic. And so we end where every honest exploration of these things has to end, not with an answer, but with a better question left gently open for another night, because the universe has not finished with us yet. We have spoken all evening about you, this pattern, repeated across endless space and branched across the quantum world, and perhaps written into every consistent mathematics there could be. But we never quite said what the you is that is being repeated. We never said what the thing is that it feels like something to be. Is your awareness a single thing that all those countless instances somehow share? Or is each one its own separate light, alone in its own branch, kindled and then, one day, put out? We do not know. The hardest unsolved problem in all of science is not the size of the universe, or the number of worlds, or even why there is something rather than nothing, though that question waits underneath everything, older than physics, the one the philosopher Leibniz called the fundamental question, and the one that only deepens when you realize that in a full multiverse it becomes stranger still. No longer, why is there something rather than nothing, but why is there everything rather than nothing? The hardest problem is closer and smaller and stranger than any of those. It is the simple fact that there is something it is like to be you at all, right now, in this room, and we cannot yet say why. That is the thread we will follow another time. For tonight, it is enough to rest in this. There is another you reading this sentence, and another, more of them than space can hold or time can count, and every single one of them is real, and every one of them feels, exactly as you feel right now, that they are the only one. They are right, and so are you. You are not the original, because there is no original. You are not a copy, because there is nothing for you to be a copy of. You are one instance of a pattern the universe makes wherever it possibly can, fully real, fully complete, fully you. And that, in the end, might be the largest and the kindest thing physics has ever had to say about what you are.